Well, welcome to today's session here at AWS in San Francisco. Thanks for coming out. We've got a number of partners here to really help us focus on how we're going to leverage open source solutions to bring AI innovation to real product market fit and solutions. I'm John Lawrence. I lead the solutions architecture function for the AWS SaaS Factory. We're a partner organization that helps our partners build best-in-class AI and SaaS businesses. We advise both on the business and technical side of the house. We're here because Omnistrate organized partners to help us understand how to build better, faster, stronger, and cheaper, hopefully. So thank you for coming. So we've got a number of partners here. We have Anyscale, Confluent, Couchbase, OneHouse, and Omnistrate. These are your speakers that you're going to be seeing today. Each one of them comes from the orientation of open source, saw a need for a managed solution, produced a world-class managed solution, and all these pieces kind of fit together in a spectrum to help us create agentic applications for the future. So you'll get introduced to each one of these as they come up on stage here. Each speaker's got about 20-25 minutes, followed by a little bit of Q&A. So please have your questions ready for them there at the end of their talks. So we're going to dive right in and say, what are we really doing here? So what's most important as an early stage company or early stage offering is really accelerating our stages of product maturity. So at the very beginning, right, we have scarcity of time, talent, cash, resources. We also don't know if what we're making has got an audience. We have a hunch. We've got to be able to test that. We've got to move fast. So a lot of us are using vibe coding or AI-driven development offerings to create that often to create the end user experience to start with. And most of us hopefully are striving for kind of no ops CI/CD and DevOps experience because as any of you have built on the cloud, there's a lot of mechanics to get on there. So this is where Omnistrate can come in and save you some time on that. So the next stage is we get to growth, the product market fit. Now we have data. We're going to manage that data. And that's where you'll see some of our partners start to fit into the picture here. And we use partner services for that. So AWS has a huge, deep bench of both consulting, but also technology partners. And that's who's here today to solve problems at a kind of level of the stack and the value chain beyond some of the primitives that you might be building on kind of bare compute and storage. And then lastly, most of us founders and early stage folks ultimately want to win the prize of the enterprise, right? That's where usually the high dollar sale is, the complexity is, and a bigger company comes out of. And really to be able to manage all of this, we also start dealing with control plane issues. How do I control all these different managed services? How do I control all these tenants I have on my cloud environments? And that's where partners like Omnistrate come in. So ultimately, when we start a company in the cloud, ideally we get to market. Many of us target the AWS marketplace as an ideal go-to-market target for PLG-driven growth. So again, you're going to see an example here with our next couple of speakers about how you get there fairly quickly. So I've been thinking a lot about this lately, like what is the stack? So I've been building on the stack since it was old days, assembly code. Don't even want to say that. So what's the modern stack today? It really is a control plane to control a bunch of high order services. We should be building on the biggest building blocks we have to build faster. In the age of AI, innovators are all using the same kinds of AI to think through, to ideate, to create PRDs, to create their user stories, and then to create their code. So time to market is really key. So if we integrate agent orchestrators, which are platforms that sit on top of the LLMs, both offered by AWS and our partners, we're able to build agentic first SaaS, software as a service companies, and then integrate managed services for data storage, data lakes, as you'll see, other kinds of compute offerings, machine learning to really help us go faster than, again, using just kind of some of the basic services. And then lastly, what we're seeing is emerging platforms. So these are platforms that help with our distribution. So platform you're all familiar with is the mobile phone, right? That is a platform of value distribution for your software as a service offering. React has kind of won the web in terms of the browsers. You see companies like Vercel having taken away a lot of undifferentiated heavy lifting for DNS and load balancing and all the stuff that was complicated before for that distribution point. So the combination of these services, to me, makes up the kind of modern high-speed development stack of the cloud today. So this is just kind of a picture of that. So on the bottom, we see what AWS and the cloud services have traditionally provided. We've got our compute, storage, and networking services that some of us are still building straight on, and sometimes we need that. But then we have higher order services that are represented by AWS partners that fill in the rest of the gaps, that allowed us to build less and assemble more, I like to say. So over here on the far left, we see our traditional, I'll call it the value endpoint, or what we would think of as the application stack, something like our mobile phone, something like our browser in a normal web application. And on the right is also now a value endpoint. These are AI agents. These are kind of a headless experience. These are the things that are doing the work for us. And then in the middle is the data core. So a lot of, excuse me, a lot of the AI-driven kind of vibe coding offerings allow us to really quickly render that end user experience. But all of that has to be backed by a really good data platform. And so fortunately, we're blessed with a lot of matured managed services, which had a lot of their starts in open source. And you can see some of them today. And then a lot of these layers get connected by a data streaming or an eventing layer or an asynchronous flow layer, we might call it. And the partner Confluent, they represent a kind of vendor that actually can bring a lot of this signaling together. So you'll see in more detail in each of their presentations how that works. We still got the AWS cloud here at the base of all of this. We can still program straight to the sort of more smaller primitives, but we can use this kind of bigger primitives here at the top. And this doesn't represent all the kinds of AWS partners that there are to build on top of, but just the core ones we're going to talk about today. So next, I want to introduce the control plane. So you've got all these services. They may be in your AWS environment. They may cross multiple AWS accounts. They may be multiple vendors. How do you control that? And that's this idea of a control plane as a service that you can introduce into your stack. So I'd like to introduce Kamal and Alok from Omnistrate to the podium here and turn it over to you guys. But it's just for the live stream. This is for the room. You need that for the room.
This one?
Yeah. And then just push it to the screen and then you're live.
Hello, can everybody hear me? Awesome. Thank you, John, and thank you everyone for coming by and stopping by here. I'm Kamal, one of the co-founders. I also have a partner in crime here, Alok, who is our other co-founder. First of all, thank you to everyone and welcome to this great event put together by AWS and some of the amazing AWS partners. So really excited to talk to you guys, people here, and a lot of people who have joined us online. So all right, so let's just continuing the thread that John was laying out. If you think about the journey a developer takes, typically they start from an idea, they build some design, they build an app, and that's usually the technology innovation side of it to bring an idea to life. But that's just one half of the story. And that's where we have today a lot of the other AWS partners who are going to come and talk about what are the different building blocks that you can use to build your application faster and quicker and efficiently. But then that's just half of the battle. The other half of the battle is to do the business innovation, to go from application to product and build your distribution model or distribution channel. Think of it like a FedEx for app distribution, right? Today, that problem is essentially solved by organization individually. We just happen to be the one who is making it easier so that everybody doesn't have to reinvent the wheel, and they can focus on building their application, focus on innovation, and solving the real problems. One of the fundamental challenges that exist is building the distribution model or distribution channel takes years to build and army to operate. With OmniStraight, you can just bring your application, bring your AWS account ID, and configure the deployment or distribution channel the way you want, and voila, you get it. And that's all about it. You don't have to worry about managing tenants, subscriptions, deployments, infrastructure, billing, automating operations, integrating with different developer tooling, either it's open source or SaaS integration. All of that is taken. And as all the world is evolving, your application is evolving, your customers are evolving, AWS is moving at the speed of light, the ecosystem is moving at its own needs, the new regulatory requirements are coming out. This control plane will make sure that you're future-proof. You're not locked into certain set of choices that you have made. And that is our mission here, to make it simpler for everyone to get to that journey. Now, in this session, I'm going to focus on the last mile. The overall event focuses on getting from an idea to product. We are going to work backwards. We are at the AWS office. We're going to work backwards. We're going to do the last mile first, go from application to the product, and then the rest of the partners will talk about the other tools that are available to make it easier for you to go from an idea to product. Oh, sorry, idea to application. My bad. So what are the different distribution models? Let's jump in a little bit in. So if you guys remember pre-AWS era, the way the software was distributed was essentially you take a package, you take an application, you package it, you version it, you give it to your clients and distributed clients, and essentially that was it, right? And customers have to do a lot of things. They have to install, they have to figure it out if the issues happen, they have to worry about upgrades, they have to troubleshoot, and all of that was manually coordinated, right? And then came the era, as you can see today, the world is moving towards the beautiful agentic SaaS, where the experiences are personalized experiences. So if you think about, for example, for when you watch movies, Netflix is what? It is one of the agentic SaaS applications. You just sit down and say, hey, I feel like just watching an adventure movie. And that's it. You get recommendation and you start playing. You're not worried about selecting which movie particularly you're going to watch. You just choose it. The recommendations are right there in front of you, right? So the level of abstraction, and if many of you have seen and been there 2 decades ago, you probably remember the experience of Blockbuster or CDs, how we used to distribute content. The same way with the software. Now, what are some of the challenges when we talk about different distribution models? So first of all, OmniStraight support all the distribution models and different configurations. So we want to be a general purpose, allow you to build your general purpose control plane that can support any distribution model. So, and there is if you think about it, there is a value proposition in having different of them, and I'm just going to quickly talk about that. So if you, for example, thinking about on-prem, even though it is one of the basic distribution model, it's still needed for the air-gapped environments or the private data center sitting in somewhere in Saudi Arabia. What are you going to do about it? How are you going to distribute software, right? There is no cloud there. So But the challenges still exist because you still have to package the software, you still have to templatize the software, you still have to version the software to create that one-click installer experience. That challenge still exists. The challenge still exists to create the seamless upgrade experience with proper versioning. The challenge still exists to have an operational CRM database where you can know who are my tenants, what subscriptions they have, what billing they have, what version of the software they are running. Is there any operational history to it? You can keep track of in your head for 5 customers. Good luck with 1,000 customers. For those of you who have done it here, know very well, no amount of people will be able to keep that in sync in their head all the time, in real time. You need essentially an operational CRM. And that's what on-prem distribution takes. But when you go to like now to BYOC, for example, or bring your own cloud, whatever we call it, you have more challenges. Now you need to be able to automate deployments. And automate deployments not only in your account, but also automate in customers' accounts securely without compromising on the experience. And then some of the customers may come back and say, oh, that's great, Kamal, but I really like security. I really don't like to maintain even an outbound connection from my organization to the provider organization because I'm just worried about security. So how do you now create this experience where they get the help when they need, otherwise they can operate offline? And then comes an experience of PaaS, and many of you may have familiar, like have seen RDS, have seen Couchbase. People who are familiar with Confluent would probably saw Confluent dedicated clusters. The experience was like that. You configure the number of units you want, and that's it. You can self-serve. You can be sitting in your comforter at 2 a.m., triggering a deployment, and getting within 2 minutes a database running in the cloud somewhere. And you can choose, you can customize it still. But the challenges are, how do you make it self-serve for the customers that works at scale? How do you make the billing usage-based? How do you now automate the operations? And you have to automate the operations such that you don't compromise, you do it that is secure, cost-effective, and reliable. And now if you go further up and look at the HubSpots of the world, Ripplings of the world, Pulleys of the world, they are living on another level, or even Confluent journey now. You go to and sign into the Confluent, you get an endpoint. You don't worry about it, where it is running. You don't even trigger a deployment. The deployment concept doesn't exist. You just get and log in, and it's just launched, is there. Use it. Many of you may have used NeonDB. You don't go and create deployments, sit there for even 2 minutes. But the challenges are, how do you now provide to the customer an experience where they don't have to worry about the performance, the scale, and the cost without compromising the reliability and security, and yet provide that beautiful experience that it can scale whenever it needs to scale. It can scale down when it needs to scale down. And then we have this Agentic SaaS, which is the new era of frontier, which is opening us. And if you look at today's experience of HubSpot, many of you may be familiar with that. It's all static workflows. The experience that Steve may have, that Alina may have, Alex may have, is all, if we are even part of the same organization, our experience will still be the same. The only difference could be that some of us may have more access control than the others. But other than that, it's same workflows, same static workflows. That is the state of the art of the SaaS today. And the new frontier of the Agentic SaaS is personalized experiences. They know if Steve is the founder of Couchbase, what experience to show as a HubSpot application to Steve. They know if there is a developer out there, what experience of HubSpot to show to them. And what does that mean now? So that is the, at least hopefully you guys got some idea that how the complexity and innovation in this distribution model exists at different levels. And what we have done here is instead of taking an approach of all or nothing, we have taken an approach of building adapters at each layer. So you can start your journey, or you can have already one of the distribution models, But if you want to extend your distribution model to other distribution models, you can do so. For example, you're starting with, you have an open source project, you have nothing, you have just container images. We can go all the way to PaaS or SaaS or Agentic SaaS you want. But if you say, oh, look, I already have an on-prem distribution, I've already built some sort of a Helm or operator or Terraform, put it together, no problem. We can take that and build PaaS and SaaS experiences. But you might say, okay, I know I actually also automated the deployments. We can make it multi-cloud, we can make it global, we can make it version agnostic, we can make it environment agnostic so your developers can work in parallel and collaborate. And pre-prod is different from the prod, and you're not testing in prod. All of those dimensions, otherwise you have to think about it. As a platform, you can think of this as a co-pilot for the platform teams to make it so simple for the, and so that application teams are not worried about now all these end dimensions. And so those are some of the technology pieces if we built. This is a little bit of the technical slide, and I just want to clarify some of the, what does it mean, a little bit more technically. So when we typically talk about control plane, it has several layers to it. One of them is the tenant management, which is like, how are you going to store your tenants? How are you going to onboard your tenants? How are you going to isolate your tenants? How are the subscription for the tenants are managed? How is the billing going to be managed? Then there's a part about the deployments, and I talked about different deployment distribution models already. Then there's the infrastructure management. How do you make a universal infrastructure management where you now are not dealing with this cloud and this region and this account and this environment and this version? You have a holistic view. You have a universal infrastructure layer on which you can operate at. What about automating the operations? So you have the security controls to achieve compliances, cost insights and controls to save cost, operational controls to reduce the MTTR and scale your operations. All of that takes a lot of time and energy. And finally, the most important piece is the integration with the existing ecosystem. Let's be honest, all of us have preferences. I have preferences towards certain tool. I may like Datadog, the other person may like New Relic, the other person may like Signos. And that's fine. And the evolution of the needs of the business may also change over time. So how do you now build this general purpose control plane that can integrate with new technologies, upcoming technologies, existing technologies in different areas, whether it is alerting, authentication, billing and metering, observability, and so on. And so for that in mind, basically we have something called control plane as a service, where you can come in and give us a spec, which is like essentially like a DSL, domain specific language, and we also have an extension to Docker Compose, and we built your control plane and deploy that control plane in your account. And from that account, it manages all of your tenants, your deployments, infrastructure, irrespective of whether the deployments are happening in your account or your customer's account. Here I'm going to just quickly clarify that control plane usually comes with two pieces, two phases. How about that? One is the phase for your customers, and one is the phase for your internal teams. Read this slide, please, as like a speedometer. So it's getting more and more complex or more and more advanced from left to right. And so this is how the customer product, like on the distribution channels we were talking about, you have the needs of the on-prem installer, then you make it multi-cloud and BYOC, then make it self-serve, you make it more SaaSify and get the agentic experiences, and so you go from there. And similarly, from the platform team perspective, they also need to know, they need to have a need for upgrades across tenants and versions, the operational visibility, reliability, cost, and how do you now have, even with the era of AI, imagine your application needs to be also integrated with the AI ecosystem, and you need to get the feedback of how it is operating and working. We have a lot of customers. I'm going to quickly show you guys a quick demo of how a simple on-prem installer looks like. This is a recorded demo of 2 minutes. And then Alok is going to do a live demo of how to do a more advanced PaaS and SaaS experiences. So you get to see in practice what each one of them looks like.
One of the most popular distribution mechanisms is on-prem installs. Startups that have built their application and are ready to go to market often begin with a basic on-prem distribution model. This is typically the first step to gain field experience and gradually build more advanced distribution channels. In many cases, on-prem is not just a short-term solution, it becomes a long-term necessity, especially for reaching customers operating in air-gapped or private data center environments, where this is the only viable delivery method. In this model, software providers ask clients to purchase a license, visit an artifacts library, choose a version, download the software, install it, and then begin using it. Day 2 operations, such as upgrades and troubleshooting, are manually managed by the client, often through direct coordination with the provider or via the community in the case of open source software. Common challenges in this model include packaging, versioning, deployment templatization, coordinating deployment steps with customers, seamless upgrade paths, collecting basic troubleshooting data such as logs and metrics, and enforcing licensing to prevent unauthorized use. In this video, we will see how you can distribute a Postgres installer with the PG Vector extension to your clients. Let's see it in action. First, let's try to log in and create a deployment instance. Note that this won't trigger an actual deployment yet, but it will create a deployment instance with an installer for your customers to deploy or upgrade. Let's select the plan and then the plan version. For the sake of this demo, we'll go with the defaults and hit Create. As you can see, the custom installer is being built, and as soon as the deployment instance lifecycle status changes from creating to ready, your customers can download and install it. Let's click on the instance we just created. You can see the deployment configuration you chose for this instance. Click on the Installer tab, and you'll see the Install Setup Guide. Your customers can simply run these commands in their on-prem environment. Let's hit the Download button to download the installer. You can now see the install script. I'll go to the PG Vector directory and run the installer. Oops, looks like we've hit an issue. To automate debugging, we also provide an AI assistant for your customers to help them troubleshoot and resolve problems. Let's paste the error into the AI assistant we've built for you. Given the deployment context, it has suggested 3 possible root causes in order of likelihood. Let's try the first recommendation and run the installer again. Voila! Your customer's installation has successfully completed and they can start using the application. In the same way, they can upgrade or update their deployments at any time and track all changes in the audit logs history. As you can see, we not only automated the on-prem installer, but also streamlined updates and upgrades, enabled license checks, templatized the installation process for easy reuse, and provided a simple portal for your customers to manage their installs, including subscriptions and billing. Finally, even though it's not shown here, we've collected all contextual information in one centralized place to give you product insights across all of your customers, right from your operations center.
Hopefully that gave you guys some idea of what an on-prem installer and some of the challenges it entails. I would now like to welcome Alok to give a live demo on a PaaS and SaaS experience and how that looks like.
Perfect. Cool. We just get settled in here quickly. 1 second. Almost. There we go. Cool. Let me just zoom in a little bit. Perfect. Hopefully everyone can see this clearly. That's great. Cool. Okay, so I'll make this quick. I just wanted to quickly show you what we have today, right? As an indie dev, startup, enterprise, doesn't matter essentially. You have a number of different personas we serve. What is your interface to essentially getting started today? And so what better way to do it than just show you, just get started right from the meat of it, which is the code, right? So we have a GitHub repo here, and this is an open source project, of course, and we'll share this with you freely. And so it kind of represents both, the models that we are trying to target, which is the PaaS model as well as the SaaS model. And especially, we are trying to show you something that's a little bit more geared towards agentic AI and how, staying in tune with the times, how does it actually work? So first step, of course, you clone the code. I already have an IDE with all of this set up, so let me just zoom in a bit here. And so it's a simple single line of literally one command, right? All the command does is it references the specification that Kamal was talking about. And as you can see, it's just literally nothing but a Docker compose. But for the Keynight, you will notice that there is some extensions that we've added, so which is basically specific to Omnistrate. And as you can see, it's literally just a bunch of extensions you add to your existing compose specification, and then we will create a portal out of it. So just to be sensitive with time, I'm going to show you what the final output looks like. So let's just pick this up. Give me 1 second. Let's go to production. Let's pick this up. So this is literally the portal that comes out of it. And so this is particularly relevant for you, especially when you have to do these things. Let's say you list this in the AWS marketplace, or you distribute the URLs or the endpoint itself to your customers, right? So I'm going to log in as one of the users here, who is a user of Data Lab. And as you can see, literally they have, again, I'm talking about specifically from a PaaS perspective. What they get out of the box is an out of the box self-serve portal where they can go in, select Data Lab, create, there's a bunch of plans that you can offer, as we were discussing, whether it's deploying in your customer's account, whether it's multi-tenancy, whether it's a single tenant isolated deployment. There's a number of things that you can offer. And let's say AWS right here, and then I'm going to fill in something and try to deploy. And I'll also show you what the final thing looks like. Again, just sensitive to time here. And the final thing is literally a summary of the deployment, the connectivity endpoint, the nodes, the metrics, live logs. Essentially, everything starts flowing to your customers, right? So this is, as I said, this is fully self-serve. Think of, you have an open source project. You need the fastest way to get it in the hands of your customer. This is it, right? Now, this is obviously great, and your customers starting to use this. This is perfect. But it's still a step a little too much, where they actually have to go and deploy this, choose the account, choose the region, all of those, right? So that's where the SaaS portion of it comes in. So the SaaS portion of it, which is where you completely abstract that out, where you provide your customer with like an outcome-based pricing or usage-based pricing, where they have no idea about the infrastructure necessary. They don't care about the region. And you maintain a much more complex multi-tenant system, which is a bunch of microservices that you put together, right? And so we also, again, this is an example of one of those things that's also hosted on top of us. And we'll be more than happy to share the documentation on how to do those things. But that's another next level of, let's say, iteration for your product that you can also do on top of us. So yeah, in a nutshell, I just showed you the PaaS journey. I showed you the SaaS journey. But then also you have the agentic SaaS journey, which is the future of, imagine code is writing itself, essentially. And how does that work? And how do those things interact with each other through MCP service? So a bunch of these things are what we put together today as a package, right? So please visit omnistrate.com and give this a shot. And of course, reach out to any of one of us, and we'll be happy to help you. Cool. Thank you, folks.
All right, in the interest of time, Omnistrate will be here afterwards for your questions. But I'd like to bring up our next guest speaker. It's Jaikumar Ganesh from Anyscale. He's going to talk about their managed AI/ML platform that also sits on top of AWS and can be an instrumental part of database focused data and analytics based workloads. So come on up. And I was interviewing him a couple minutes ahead of this, and really just found that if you were to have to manage all of the fleets and nodes and compute under the hood for all your ML, that is a heavy lift. So I can imagine having any scale and then having that even through Omnistrate just takes away a huge amount of operational burden. So anyhow, let me turn it over to you.
Cool. Thanks a lot. How's everyone doing? Right? Afternoon, second talk. Did Kamal bore you? No? Yes, good? Okay. All right. My name is Jay Kumar, also go by JK. I lead engineering at Anyscale, and previously I spent some time at Uber ML Infra, as well as was one of the early team members at Android way back in 2006. So Kamal talked about how you take an idea and try to get it to product and application. He's now happy and excited. Oh, I have a control plane solution. I have all these awesome agents that I can actually build. So many use cases that were not possible before. Let's get into it. He was an ML developer. He started his doing structured XGBoost model some time back. Then deep learning came along, and then he started doing it unstructured data. Hey, I can process a lot more of data much more faster. And now generative AI has come along. You have your audio, video, chats, conversation agents. You run on GPUs, CPUs, multi-node distributed stuff. He's like, all right, I got this. Let's go. So he's got his data sources. He's got his data sources, sensor data. He's got audio, video, structured, unstructured data, everything there. Then he says, OK, I have 1 million models on Hugging Face. I need to pick one. Let's start with data pre-processing. I have Spark, I have NumPy, I have Pandas. Oh my goodness, I've got CPU infra team to deal with. That's fine, he figures it out. And goes to, OK, I can train a model now. Which framework should I use? Should I use PyTorch? Should I use TensorFlow? Should I use XGBoost? Oh boy, and I have to deal with GPU infra also. All right, he's somehow figured it out. He's smart anyway. And then he's now coming to model serving. And now he has got the latest LLM inference engines. VLLM, TRT-LLM, deep speed, CPU and GPU infra team. This is a lot. How many of you have gotten stuck trying to build an AI application and just gotten stuck by the complexities and the entire frameworks changing every single day, right? I saw a few hands go up. We call it the AI complexity wall. Right? So it's literally a wall that Kamal is now frustrated, and he's hitting the AI complexity wall. And here are some data points. Only 1 in 10 AI projects actually make it to production. People get excited with all the latest models and do it on their laptops, but only 1 in 10 go into production. 93% of companies leave their GPUs unused. Unstructured and multimodal data is growing, and models and frameworks are growing fast in size and complexity. Ray was actually built for this. So Ray started as a PhD project in around 2016, 2017. It basically has 2 concepts for a user. It's a Python function, we call it tasks, and a Python class, we call it actors. You don't have to look at the code, but it's basically on the left-hand side, tasks is taking a matrix multiplication and just distributing it. It has like 4 or 5 APIs. And then actors has some state. So here's a counter that you can actually increment, and again, you can actually distribute all of these things. So below it is Ray Core. And so Ray Core is what is a compute substrate layer. It takes care of all your CPUs, GPUs, has a scheduler, has a distributed object shared memory, takes care of all these nodes. If a node crashes, it brings it up, etc. And then on top of that, we have built various machine learning libraries. Serve for serving your models, data for data processing for the models, training the models, reinforcement learning, and LLM and post-training models too. So initially, around 2019, Ant Group was the first company which actually started it, using Ray a lot. And then Uber, I was on the Uber side, we started using Ray internally for building ML platform systems, and Michelangelo is a famous framework from Uber. And then Pinterest also started using it a lot. So these were like 3 of the big companies who were using open source Ray and working with us and driving a lot of adoption. And then generative AI came along, and this just exploded. These are all some of the companies, and Amazon here too, and quite a few of them started using Ray extensively. Every single day, I hear about one new company using Ray. Tencent uses it for WeChat extensively. Just last week, we came to know that X.AI is using it for data processing. Thinking Machines, that's the latest startup, is also using Ray internally. So this ecosystem has grown a lot. All right, so I want to take a step back and talk about all the trends that have happened in AI over the last 1 or 2 years. So data processing. Initially, it started with SQL data in tables. It's gone now into multimodal data with images, video, audio, text sensors. Data was basically, you process the data and you have some batch stuff. You can write some SQL queries. That's how it was being done. But now it's tightly connected to inference. You have a chatbot and you're asking something of, say, a legal document, right? So you have to process the data and also do inference on it at the same time. From CPUs, we have now moved to CPUs plus GPUs, plus all the custom TPUs and inferentia chipsets and various other hardware frameworks. So there's a shift in the nature from SQL on CPUs to inference on GPUs. That's actually happening and continues to happen. The second trend is agentic AI. These are two figures that DataRobot actually published on what it takes to build agents. From one model, it's gone to a compound AI system. It's a collection of models now, right? Now you have a RAG system, that's fine, but now you need a ranker on top of it to figure out how do you actually rank the results. You need an embedding system to figure out what kind of embedding you want to use. The programming model has changed, right? Initially, we used to write code in C, C++, etc. Then it went to neural networks where you're changing weights. Now LLMs and prompts are become their own programming model, right? So now you have to do prompt management. How do you actually do that? You have to deal with prompt injection and stuff like that, right? Which is the LLM that I need to choose? There are some LLMs which are good for one single small node and some models which are big with higher accuracy, for example, but need multiple nodes for that to run, right? So there's so much more complexity that is actually to be handled to build these agents. And Ray is best suited, again, to take care of this for you. The third trend that's coming on is post-training. So you have this pre-training, which is like, all the LLM models that started a couple of years back. They had this first models that they used to run on large number of GPUs, some open source like Llama, some proprietary coming from Anthropic and OpenAI. Now, post-training is a trend where you take one of these models and you train it for a specific purpose. Now, if you're an agent, say if you use Cursor, right, and your Cursor is using a post-trained model which is developed for coding, or if you are using one of the reasoning models, latest ones from OpenAI and O3, that's also a post-trained model, right? A lot of the post-training frameworks are actually built on top of Ray. OpenRLHF, Whirl, SkyRL, all these are famous open source post-training models. They're built on top of Ray. So let's take a little bit of a deeper dive over here. So the pink box that you actually see is still the learning algorithm. It usually uses PyTorch, FSDP, or Megatron if you're familiar with those frameworks. And then you have this inference, which is an actor, which rolls out your rewards, and you have to infer it. And now you have a loop. So you are a coding agent now, and you are suggesting some steps. Now you have to run a unit test, for example, and you have to come back. So you actually interact with the environment a lot. And that's what agents will have to do. If you have agents with which are connecting to multiple other agents and multiple other models, and they're doing like solving a problem, they are optimizing for a reward. And you have to train that agent for that reward. They have to continuously work with the environment, right? It's very different from the olden times where you have a model, recommendation model, for example, you click a button, you get it, right? It's now you are in this continuous loop. So what happens is that what runs on CPU? What runs on GPU? How do I actually move the weights from one node to another node? How do I actually combine all these aspects, right? And this is where Ray, again, comes into the picture. Many of these post-training frameworks are actually built on top of Ray. All right. So I talked about the AI data processing, agentic AI post-training, the AI workloads. Obviously, at the bottom of it is the compute substrate. You have your cloud providers, AWS and others, your specialized GPU providers, etc. and the AI infra software stack sits in the middle. Right? This picture is from Roblox. They published their entire AI infra software stack. You have various parts of it. So you have the compute substrate. You have like frameworks. Then you have the real-time inference engines. You have all your data stuff on unstructured data, data structure, your feature stores, your tables, etc. And then you have something like if you need streaming framework, something like Kafka to connect all these components. And then you have your testing, experimentation, and monitoring frameworks. So let's abstract it away a bit more. So let's talk about training and inference frameworks. There are basically two main frameworks here: PyTorch and JAX. JAX is now only on TPUs. PyTorch has become the dominant one. And because of the size of the models, you have to have different parallelism strategies, right? And so FSDP and DeepSpeed are two major frameworks that drive the different kinds of parallelism strategies. And for the LLM inference, these are the transformers. They get their own box. It's no longer just serving a model and running up a service and serving a model, right? You have to think about if you're familiar with the LLM space, you have to think about things like chunk prefill. How do I do prefill and decode stages? How do I actually make sure that continuous batching? Because again, every single token that you type in, there is an inference engine that's actually running. Can I predict what the next word is going to come so that I can save my costs? Many times, if there are multiple users sending in the same request, they all have shared prefixes. Right? What's the weather in Palo Alto, or what's the weather in San Francisco? So I can be smart enough that I can know that what's the weather is actually a common pattern. So there is so much complexity over here within LLM inference engine, and this is continuing to grow. So VLLM is one of the most popular open source LLM inference engines. Then the distributed compute layer is where Ray shines. Ray basically makes sure that it takes care of scheduling, it takes care of auto scaling. And Spark was there for the ETL data processing, and we're also seeing some homegrown solutions over here. And of course, you have the container orchestrator. Kubernetes is the leading container orchestrator. Some of the ML research groups use Slurm. The reason for that is Kubernetes is just too complicated, and Slurm is a very simple job manager, and you also have VMs. So I'll just pause there for people to get an idea of the evolving tech stack here. Right? So I'll give you some examples here. This is all from open source. Instacart was able to train larger models using just 100x larger training data. Niantic saw developer productivity, and Amazon moved to Ray data and were able to save around 100+ million in cost by using Ray data for their data processing needs. The Ray community since 2019 has grown a lot. We host a Ray summit every year, and there's one more in November. This is right here in San Francisco. I would encourage people to attend that. All right, so let's come back to Kamal. He gets it. He understands the AI complexity well. He says, okay, fine, you've explained this to me, but what do I do with it? How do I apply it to my use case? Right? So let's take a simple use case and deep dive a bit. So he wants to process some multimodal data. Right? And so I'll give some of the APIs that he can actually use to develop his application. So multimodal data has grown a lot. Obviously, it's being used in healthcare for analysis of X-rays, etc. This has been going on for some time, but it's actually going to increase a lot more. Sensor data is flowing from various geolocations. So think of Uber, Lyft, or Waymo, etc. They're all collecting data, and they have to make sense of the data. Industrial automation has picked up a lot, and of course robotics, right? So all of this is generating a lot more of multimodal data. Market cap also is supposed to grow, from 1.7 billion to 68 billion in the next 10 years. So the question for us is, what's the best data processing framework and architecture for handling multimodal data? Firstly, do we need to change anything? What was working before, will that just continue to work? Will it be efficient? So previously, the core assumptions we were making was that data is structured and tabular. Bottlenecks are CPU and memory based, and operators are cheap and lightweight. They were based in Java and Scala. Right? If you have dealt with it, you deal with ETL pipelines, your data frames, your SQL queries. AI data processing systems have changed the requirements. It's not just tables. Now you're dealing with tables and tensors, right? Bottlenecks are not just CPUs. You have GPUs, CPUs, and memory. Sometimes between stages, you may have to materialize the data, or if you don't have enough memory, that's going to have an impact on the throughput of the system. And because you're dealing with so much amount of data, operators are going to be heavy at every stage of it. And the AI ecosystem is in Python. So Ray Data is a data processing engine that's actually built for AI workload. It has support for multimodal data from the ground up. It's not like bolted upon on a legacy system. You have readers for images, video, data. The backend is based on ML frameworks like PyArrow, NumPy, Pandas. It has first-class support for GPUs, TPUs, optimized GPU pipelines, and can handle both CPUs and GPUs at the same time. The stateful operators, because for expensive GPU state, you have to have stateful operators, and that's actually built in. And it's written in Python, supports all the data sources, Parquet, Iceberg, Delta, Hootie, etc. And then it also has integration with inference engines. Coming back to the point I made, it's no longer just regular processing, it's regular plus inference. So Ray Data works with VLLM as well as GLang, two of the famous open source LM inference engines. Let's take a quick dive into the API. So you have standard read and write APIs, right? Parquet, JSON, etc. And you have connectors to all the DBs. You can do a transform on the data. Hey, I want to map batches, basically distribute my processing on it. You can consume the data. I just want to iterate through the rows of the result, just take one. I can do aggregations. So anyone who has worked with data, all of this will be pretty familiar. I think the difference here is the compute APIs. You can actually now specify your CPUs, GPUs, and the concurrency that you actually want to provide. So let's take an example. I have a standard computer vision application, right? I have a bunch of images. Say it's there in my S3 bucket. Now I want to make sense of these images. I want to classify these images. So now I'm going to have these three stages. I do resize these images. I have a segmentation model, which is going to segment the images. And then I have a classification model, which is going to classify it. And then I'm going to write the images down. And for the keen eye, you'll notice that these are three stages. There are three map batches operations. And you'll also notice that segmentation model, the concurrency is different than the classification model. So I can actually control, hey, this just requires one GPU. This can be done in half fractional GPU. And this can go with a concurrency of 8. This can go with a concurrency of 4. So what does it look like in an array cluster? We have some tasks like resizing of image, good for CPU. Segmentation model and classification model requires GPUs. So we run that on GPUs, and then we are able to write it back using CPUs. So the two key aspects here is heterogeneous architectures. You need to do CPUs and GPUs at the same time. And the second thing is your data is streamed through memory because it's built on Ray core. So after a stage, it's not like, oh, I have to write it back to the S3 bucket and then load it in a GPU. For the legacy systems, that's how you need to do it. And the fun part is that it's also streamed. You don't have to worry about it. And the execution can happen in a streamlined way. So what do I mean by that? Suppose you have 1,000 images, 100 of them have been resized. You can send it to the GPU, and the GPU can start working on it. You don't have to wait for all the 1,000 images to be processed by stage, and then you lose your GPUs idle. Same thing with the classification model. These GPUs are not cheap, and utilization is an important aspect over here. All right, you'll see a lot more details on docs.ray.io. This is like all open source docs. All these use cases, examples, everything is actually provided over here. So I would encourage you to visit there. You have tons, like all the libraries, examples, etc. All right. So now Kamal gets it. He's like, I know what to write. He's written like pip install Ray and figured it out. But getting everything out of Ray requires a lot of major investments. We have seen teams get blocked in getting started. and they run into production, and then they expand across teams, right? This is where AnyScale comes in. Right? AnyScale takes infrastructure away from you. You don't have to worry about it, especially if you're spinning up infrastructure on top of Ray. So developer velocity. So Ray is like a Formula One engine. It really requires an expert to truly understand what they're doing, right? But it comes without the rest of it. It doesn't have the doors, the seats, the knobs, etc. And so we have a developer experience portal. We have observability. How do you better manage the instance? What about costs? And if you have to do an upgrade, etc. All comes in packaged at AnyScale. Production resilience is the thing. You may run Ray, you will run out of memory, your GPUs will fail. What happens when you have to checkpoint a job? That resizing image, what happens after your GPU fails after 10 images, right? What happens when you have a spot instance and you want to move to the spot instance, but you got preempted and you want to go back to the on-demand instance? The control plane can also be intelligent, and you can have the Ray control plane. You can have job level retries, you can do checkpointing, etc. Cost matters to everyone, right? So we also have optimized runtime within AnyScale of Ray. And so this is elastic training using spot instances, making it easier for higher QPS. And then when multi-AZ deployment, as well as scheduling based on when your reservation when a node is available, say on the weekend, we can actually schedule those jobs. So this is basically Ray on AnyScale, heterogeneous infrastructure, bunch of ML use cases that can be built with them. Some of our customers, like Runwave, which is a GenAI company, deploys it in production. Attentive, Coinbase, etc., have seen lots of improvements in their developer efficiency, in their production, and their cost use cases using AnyScale. All right, let me do you a quick demo here of our developer experience. So you have this concept of a workspace that's there. And here we are actually creating an audio application. And you don't have to worry about worker nodes, for example. You say, hey, auto select nodes. That basically means that we will figure out the right instance to actually use an auto scale, etc. You are integrated with your VS Code, and you're writing some code over here. As you run it, you said, oh, I don't have a dependency management problem, no module named datasets. Now, if you're doing a distributed applications with dependency management, what do you have to do? You have to go to every single node SSH and install the dependency. But we have actually created this where a container image using a Docker, this automatically will install to all the worker nodes without you having to actually and restart and get going, right? And so now when the user runs it, it'll actually work through it. There are other aspects too over here. So for example, now we automatically auto scale. So you can see this on the top right, this one node, and now it's automatically scaling to 2 nodes without you actually having to worry about it. And this is where the power of Ray comes in. You want to metrics, how the hardware is being utilized. If you want to know, hey, what is my utilization of my CPU, GPU? And then if you want to go deeper into the workloads, logs, etc., everything is available in a single pane. This is something that is really resonating with our users, that one single plane where they can actually develop their application, see what's happening with the Ray cluster, and also deploy into production. All right, to recap, newer modalities of data processing, agentic AI, post-training, different use cases is leading to the AI complexity war. Ray was built to solve this, and AnyScale makes it easier to take it to production. So you can try today. Go to console.anyscale.com. You can try today. We have an open source community. You can join there. You can get expert training. Like I said, Ray is still an engine, a Formula One engine. You can get expert training to actually learn more. So hopefully our AI developer who started with an idea, ran into the problems, found a solution, and is able to deploy it into production. With that, hopefully this was all useful to everyone here. Thanks a lot.
All right, while our next speaker sets up here, I'd like to introduce Gaurav from Confluent. Their tagline is essential nervous system for your organization, right? So when you think about agentic workflows, it's a lot of kind of little bots and worker bees behind the scenes picking up things to do and then having to do them and then handing off the output to the next thing, right? So having a streaming data platform, sometimes we call it a service bus in a small scale, Kafka at the large scale, is really essential to kind of stitch together, get all the value out of your data platform, and stitch together these agents. So with that said, I don't want to burn too much of your time, Gaurav. Thanks for joining us.
Thank you. Well, good afternoon. My name is Gaurav. I'm a VP of Engineering at Confluent, and very excited to talk about how Agentic AI and the data streaming ecosystem works well together. Very quickly, Confluent really has been built on the massive heritage of Apache Kafka and Apache Flink. These are two very famous as well as like highly contributed projects, and Confluent has been able to like productionize them, get them to build a proper data streaming ecosystem. We are able to basically help our customers stream, connect, process, and govern their data, starting this whole virtuous cycle of setting the data in motion. A lot of scale, multiple different clouds. Over the last 10 years, I believe we have honed the skill. As you can say, we have multiple different verticals, a lot of Fortune 500 companies, and as the talk is all about, if you want to get from an application to a product to a matured ecosystem, we need to be able to build all of the enterprise-grade features. So that's what Confluent has been working on. To start with, I'm going to touch on how data is gold in this entire AI rush, how streaming is going to accelerate this agentic AI ecosystem, and then we'll build like a small, I'll demonstrate it. It's a slideware, but a demo of leveraging most of this best-in-breed technology to have your agentic AI workflows being built. So to start with, in this day and age, data is truly fueling the AI businesses. You can see that different verticals, you take finance, customer success, marketing, obviously software development, large-scale ecosystems. Data is what is differentiating various different AI ecosystems and what. We are entering into this third phase now. You know, we started the world with a lot of custom-built models, custom AML. Then we had this massive inflection point with RAG. Obviously, everyone got a touch of that. And slowly, we're getting into the agentic AI ecosystem. This is where, what do you mean by agentic AI? Basically, AI is able to take actions on your behalf, think through, process, understand, and then act on it. And the way to get that is through effective, good, well-curated data. That's going to be where the key of the moat is going to be. You have heard this many times. Agents are the new apps. This has been well popularized by multiple different strong celebrities in the Bay Area now, in the Silicon Valley. What we would like to add is fast, relevant, and real-time data is what is going to make this golden. I specifically want to talk about the relevant because this is where your data is well curated, structured, governed, has the right policies, has the right kind of IAM roles, and so on. As AI gets more and more into the enterprises, this is what is going to be the key differentiator. This is no more like a small toy project or a mom and pop shop. This is actually getting agentic AI into the large-scale industries and enterprises. Agents are going to be a lot more on the right-hand side, which means they have the agency, they can make decisions, and they are completely autonomous, which means the way you can actually control, mutate, and train them is through effectively context-based data. Now, agents just don't work on one ecosystem. Very quickly, it's going to be an extremely complex world. Agents need data from external systems, from your internal databases, from logs, from tables, or from other agents. Now, if you go into an enterprise and try to have your agentic applications or this entire ecosystem work effectively, you will find it very quickly that the data in a certain enterprise is very hard to get. It's a lot of data, huge complexity, and there is no easy way to mine this effectively to make sure your agents are smart. Why is that happening?
Traditionally, data lies in two different entities. There's an operational data estate. Think about your source of records, your databases, your simple logs, or on the right-hand side, the analytical estate. This is the post-action, after-fact review, your analysis engines, your reporting engines. Now, to make sense of all of this, it's a quadratic or an exponential explosion of point-to-point connections to make sense. We have this operational estate and the analytical estate trying to connect to each other to make sense of all the data coming together so that could be effectively used. Context-based, relevant, role-based, secured, all of that. Unfortunately, it's a giant mess, and to add to it, if we don't think through the agentic AI architectures effectively, we're going to be building on top of this giant mess. If we end up building our agentic AI applications on this mess, they're not going to be very effective. They're not going to be super developer friendly to be productive, and scaling them is going to be extremely challenging. Now, those of you who have known to build systems and have seen architectures evolve, any type of challenge at the lower layers means the layers on top, built on top, become exponentially more challenging. Now, agents are going faster. As I said, we are into this third wave of innovation, and agents are actually taking it on slowly, but they are going to accelerate very quickly. And multi-agent ecosystems are going to be a norm. Agents are not there just as a one-off flurry of an app to work with. It's an ecosystem, and they're always going to be working together in tandem. There are these 4 patterns that were published. These are design patterns for future agentic applications. And you have the orchestrator-based model, the hierarchical model, the market-based, and so on. Why am I saying all of this? Because it's very true now. We are entering into a world where, again, agentic AIs are going to be right there. That's the norm. The complexity is not getting simpler. And the data, the critical data that they need, is not easy to harness. We are going to be in this world where these complexities growing with time, and the interdependencies are going to be super tight to navigate. Now, if you squint at it, this is not a net new problem. We as an industry have dealt with something like this when the whole microservices explosion happened, maybe in the last decade. We knew this. We saw the point-to-point communications not being able to scale. We saw the whole catalog and management of services becoming harder and harder. And we solved it. In most cases, we solved it by thinking about an event broker or an event-based model. Why? Instead of building this, again, exponential or quadratic point-to-point communications, we brought in these event messaging models to be cohesive, single highway to go from the left-hand side to the right-hand side. Or, most importantly, build feedback loops that are required to make these services be effective. Let's take that as a paradigm, as a model, and then apply the same thing to our agentic AI models. We believe the future of how these models are going to be built are completely going to be event-driven, because that's the only way you can scale them, decouple them, simplify them, and keep continuing to build and innovate on top. This is where some of the top technologies like Kafka or Flink come into picture. It's well known Apache Kafka can actually help you simplify a lot of these communication boundaries and limitations we have. And to add to it, Flink can help you be real-time when it comes to querying, read or write or change or map or shuffle or do all those operations. This is where we believe data streaming is the new paradigm on which this entire agentic AI ecosystem is going to be built on. Now, I keep coming back and saying that it's not just about building simple applications, but truly being enterprise grade. So it's not just about ensuring you can have a streaming platform that just helps you stream, but you need to be able to connect to various different ecosystems. So that interconnectedness is super critical. As you go and sell into enterprises, as you go and build into up the vertical, you need the right governance in place. Because without governance, there is really not a serious business that would like to have AI being introduced. And then you want to have the ability to process. And process in real time, on the spot, or process and offload and processes outside of the systems. So this is where an entire ecosystem of what Confluent is building comes into the picture. It's an end-to-end data streaming platform that allows you to A, connect to multiple different ecosystems, stream your data at near real time, extremely effective, cost-efficient way, govern it with the right set of policies, structures, schemas, and at the same time, have a lot of control that developers want as well as the enterprises want. As you can see, the end result is you can get a lot of data, pass through the system, and build what we call as data products. Because if you're building AI on top or leveraging this as in between your flow as a feedback loop, you need rich data products because that's where the real golden value is. Once you have them, build on top, rinse and repeat, have feedback loops, everything just works. Again, because of the connectivity to both sides, you can get in data from one side and then publish or send it to either your warehousing agents or other AI apps or some fancy reporting tool, whatever you want to pick. So it's very clear that future of agentic AI is event-driven, and we as an industry are well situated and well positioned now to take this on. There's a lot of advantage of being event-driven, obviously, extremely efficient. There is being scalable, being decoupled, fast. There's a replayability because the storage is durable, which means you can actually think through, plan, reprocess. That feedback loop, especially in the agentic AI world, is super critical. That's what has helped through the event-driven ecosystem. So just to build this home, the Confluent data streaming platform sits in the middle with the attributes and capabilities of being decoupled, being real-time, cost-effective, scalable, kind of work on different clouds. You can connect through various different sources on the left. Now these sources could be human-generated, machine-generated, or just sample logs. It doesn't matter because ultimately you're picking different sources, connecting through well-defined connectors, and then publishing them through this unified highway or the workflow management. And ultimately they end up on other AI systems or in your warehouses, or maybe there's just a feedback loop for a simple agent to push it back into the streaming platform. Obviously the advantage here now is we are getting highly scalable, governed, well-defined data to flow through the systems. I have the next picture just to show the exact same concept, but purely thinking about agents all the way. So it's agents on the left, agents on the right, and this entire event-driven ecosystem in the middle. Again, it's not just about the technology, it's about building matured enterprise-grade scalable products, which means you need the bells and whistles that are required for the governance, for the policy management, for the scaling, for the cost, for telemetry, and all of that. That's where the package is. None of this would be possible unless you work with our partners, and obviously we work with the top cloud providers. AWS has been a fantastic partner for us. This is where we see a lot of co-gen, co-value creation. We also partner with the top AI and other warehousing tools. You have the Databricks, the vector databases, the Snowflakes of the world, along with a few other partners. You can see some examples and war stories from Notion, Reworked, Airy, who have actually built a lot of the AI and agent workflows, already leveraging the Confluent ecosystem. Now, I did say that we are going to talk about an example of how you could think about automating maybe one of the workflows. I'm picking the most common, the most famous SDR workflow. I don't know why, but you drive on coming into San Francisco, all the ads are about how do you automate SDRs. I don't know what those guys did, but somehow this becomes like the top use case to talk about. So here I am talking about that. Very simple, it's a lead gen, pipe gen opportunity, identifying an opportunity, reaching out for a campaign. Just like the rest of the valley, we believe this is going to be replaced with agents who are smart, who are capable of thinking real time. If I had to build this today, I would essentially design it this way. Again, connectors to come from your Salesforce and other places. The data comes in, you classify, you categorize, you feed it to other feedback loops and intelligence systems. On the right-hand side, you see a lot of those general value creation mechanisms that are feeding the data back. We then push to Flink, which can then go make your inferences, an intelligent analysis, get the data back. If you need to use Connect, push it out into your campaign management systems, and that's the entire workflow. Again, these are all pieces of technology built on our top cloud providers like AWS, right out of the box, stitch them together, and your agents start working. So I'm going to leave you next with a few quick slides about what's already available. As a developer, as a company, as a founder, you can just go try them out already. Obviously, I'm not covering the entire data streaming offerings, but specific to what's relevant to the Agentic AI ecosystem. We have model inference capability in the cloud, shipped already. It's ready for trying it out. We partner with the top AI model companies. We also have native support for launching compute with GPUs and certain models natively within the ecosystem. We have connectors for your most famous and common vector databases that you can leverage for your interconnectedness and queryability. Flink on its own natively can support search for the top 3 vector databases, again, mostly for AI workloads. And then we have a few forecasting, decision-making algorithms already pre-baked and built in. And finally, you can do lookups as well as needed. So yeah, at the end of the day, the take-home here really is, we believe Agentic AI is going to be event-driven. Data streaming ecosystem and data streaming platform is that new paradigm that will kick it off in the next notch, accelerate it further. And then a lot of the tools, a lot of the technologies that are available out there in the industry at an enterprise grade, as I mentioned, are available for you to go build on top and get done quick. So that's it. That's the talk I had. Thank you so much for the time.
All right, so we've got 2 more presenters. Quick question, can everybody hear the presenters without the handheld mic? Yes? Because we can lose the handheld mic at that point. Great. So our next presenters are with Couchbase. They are a NoSQL data store and then some. And I don't want to spoil their surprise here. So yeah, I learned a lot about Couchbase today, talking to the folks here from Couchbase, and really, I told them that I'd probably spoil my whole weekend actually trying it out. So anyhow, we're a little bit ahead of time, so we do have a little bit of space, not too much, just a couple minutes. But that said, my 2 presenters here are Steve, who's the founder. You were the founder of the open source offering, yes, and his engineering manager, Tanya.
I'm Talina.
So, and I don't even pronounce her last name. I've already forgotten how to do that. So, anyhow, so if you 2 want to just speak up, I'm going to turn this mic off. Make sure you, Talina, turn your mic on there for our streaming participants. And away you go. Thank you, guys.
All right, thank you very much. John, that was a very kind introduction. Thank you. Also, AWS for putting on this event, and OmniStraight, too, for shepherding this thing. So, yes, my name is Steve Yen. I'm one of the co-founders of Couchbase. But be not afraid, I'm, like many of you, a technical guy. So afterwards, come ask me questions, whatever you want to ask, whatever you want to talk about. It'll be fun. So agenda-wise, we're going to talk a little bit about our SaaS lessons learned. What were the lessons learned that we had? Ideally impart some of the challenges that we ran into in terms of standing up our database as a service. And my co-presenter is Talina, and she is one of our top engineering managers who worked on the DBaaS product. So there we go. First of all, we're going to talk a little bit about what is Couchbase, and I do have, I guess, this bias or this opinionated thought that, yes, Couchbase is one of the probably most underappreciated or underrated technologies or data platform databases that you all probably are not familiar with. So good news, you got to hear about it today, right? And back in the day, I was involved in a lot of different technologies. I remember multiple decades. John mentioned doing assembly language programming, and I remember those days like crazy, and all the different waves of technology from PCs and client server and internet and onwards to today. And today, nowadays, we're involved in AI. It is the most exciting, the most amazing technology shift, the tsunami, this tidal wave of change that's going to be happening to our industry. And oh my God, it's going to be crazy. It's going to be exciting. So, and we're also going to talk about our SaaS lessons learned. Now, what is Couchbase? Couchbase is a very fast, high performance SQL++ document database. And what I mean by documents, I mean JSON documents. Back in our early journey, some of you might remember this wave or this phase of the industry called the NoSQL wave. And Couchbase was an early NoSQL startup. And what we did is we adopted in our early days the JSON data format. We made the bet and say, hey, it feels like, hey, is it going to be XML? Is it going to be something else? It feels like JSON is going to be the thing that, like, there's going to be more JSON than ever before in our lives. And when you layer on, like, yes, all your applications are probably generating JSON left and right? So it was the right bet. But you layer on top of that AI. Is AI, agentic applications, going to be generating more JSON or less JSON in our futures? Well, yeah, it's going to be more JSON. So not a bad bet. But what are people building with Couchbase? Well, they're building global applications. So in these global applications, they're mission critical, business critical. They need the highest performance. You're talking millions of ops per second, super low sub-millisecond latencies, all sorts of things that are like, you need highest availability, highest reliability. These things have to be robust. They cannot go down. And they might need to be distributed, not only within a single cluster, which you can do with Couchbase. You can add more and more server nodes to a single Couchbase cluster in order to scale it out, in order to have more performance. But you can have more than one cluster, and you can have an AWS West cluster synchronized up with an AWS East cluster, an APAC region. You might have some other clusters or hybrid cloud or your own on-premise installations. All are part of Couchbase features. This cross-data center replication, done. If you want to say, hey, Couchbase, can you run this stuff for us? No problem. We have our database as a service. It's called, the product line is called Capella, but we will handle that for you too. There's also a lightweight version of Couchbase called Couchbase Lite that will run in iOS or Android. So on your pocket, in your purse, on your tablet, in your kiosk. And if those devices on the edge are occasionally disconnected or occasionally connected, no problem. That synchronization, that replication, that conflict resolution, those are the feature sets of Couchbase, of the Couchbase data platform. So let's talk a little bit about like different companies or different industries that have actually chosen us. There's like from retail, from travel, from technology, telcos and gaming. One of the companies I like to talk about is related to this quote from science fiction, which is about, hey, the future is already here. It's just unevenly distributed. And I got to tell you, the future is already here. It's just already distributed to cruise ships. Now, cruise ships are amazing things. So you're talking Carnival Cruise Lines, Princess Cruise Lines, Royal Caribbean. These are like customers that have deployed Couchbase. And when you think about like a cruise ship, it's like, well, take this building that we're in right now, flip it over onto its side, and like, decide to make that move through the ocean. That's crazy. But the amount of IT technology that they have deployed in these cruise ships is also crazy. It's censored up the wazoo. Thousands and thousands of RFID sensors deployed in cruise ships. Why do they do this? Well, when you check in for your cruise, they say, hey, by the way, have you installed, sir, this Carnival Cruise Lines application on your smartphone? Oh, let's give you this RFID pendant. Let's give you and your family this wristband, so that while you're on your cruise and you're enjoying yourself, you could say, hey, well, here, you come up the elevator onto the 19th floor, the 19th deck. Holy moly, 19 floors on a moving boat. That's already amazing. And the elevator doors open. And you see these beautiful, wall-to-wall screens. And it says things like, oh, by the way, hey, there's scuba diving lessons that are going to be there in the next 2 hours. Would you be interested? Talina might be exactly interested in that kind of thing. There are drinks 50% off on the Lido deck. That's a thing that I might be interested in, right? And it just happens to know stuff like that. So the amount of data that you have behind the scenes in order to slice and dice it and provide the right information at the right time for the right experiences to increase the value for the guests, is there going to be more of that in the future or less? Well, there's going to be more, right? The applications that you can build on top of that kind of data layer. If you aspire to that kind of thing for your applications, whatever you're trying to build, please take a look at Couchbase. Now layer on top of that AI, in the terms of the LLMs and generative world, right? To provide the right kind of experience for the user. That's going to be crazy. So we're very excited by these kind of things. I mentioned this thing called SQL++ rather than taking up all the time. Basically, we worked with the father of SQL. His name is Don Chamberlain. Mr. Don Chamberlain, he's an IEEE fellow. He's an ACM fellow. He was one of the inventors of SQL. But we decided, hey, Don, if we were to extend SQL to the semi-structured world, not just flat rectangular tables or relations, but if there's substructure, if you have a product JSON that has sub-variants and sub-manufacturers, and you want to slice and dice it, how should you do that? Well, there are new operations like unnest or nest and all sorts of cool things in SQL++. Check it out. It's actually sort of a de facto standard now. Not only do we implement it, multiple open source projects or SQL engines or data engines now implement it. AWS has an implementation of SQL++. Very cool. And now AI can access this kind of semi-structured data very smoothly. With that, I'm going to turn it over to Talina. She is going to talk about Capella, which is our database as a service. So,
Yes.
all yours.
Awesome. Hi, everyone. Very nice to meet you all here, and thanks for attending, and thanks for listening to me. So, thank you, Steve. You shared your experience of actually building a NoSQL database from scratch as an open source database, which is highly scalable and performant. And I think at this stage, at Couchbase, we had a database that was serving the needs of offline availability of data, online availability, and it was also cloud native. The question that was in front of us at that point was, we've nailed the 0 to 1 journey. How do we go from 1 to n at this point? And that's where I think a lot of this work on database as a service was inspired by direct conversations with a lot of our enterprise customers. They were loving using Couchbase, and then they were like, hey, but can you please also operate this database on our behalf? We don't want the operational overhead. And then scaling the database as, let's say if there are millions of reads and writes happening, you want to scale the compute, you want to scale the storage. That's an overhead for customers. And that's where Capella and the need for Capella really came up. Our goal was to create a fully managed database as a service offering. But our database, as Couchbase, most of our customers were large-scale enterprise customers, usually in the financial and health sectors. They were scared or worried about and very deeply concerned about 3 things: confidentiality, integrity of their data, and availability. So at this point, security was at the core of our DBaaS offering. We had to make sure that what we are building is guaranteeing a customer that their data is safe with us. It's not leaving the perimeters of private virtual cloud, and it's not going over the internet, for example. So that's where we built the generation 1 architecture of Capella. And at this point, we decided, let's provide a simple toolkit to customers with a simple control plane and a simple data plane. Except the data plane is completely owned and managed by the customer themselves. So all we did was we provided a management plane based on Kubernetes, and the infrastructure and the AWS accounts were all procured and fully owned by the customers. This ensured that there was data integrity and security because the data resided in the customer's AWS accounts. And Couchbase was just provisioning and orchestrating the database, scaling it up, managing and observing what's happening to it. So this worked really great for us when we started DBaaS in the V1 era, and it was a good inflection point. We were able to get customers migrating from on-prem onto cloud, but soon we started realizing a few difficulties. I think after we got our first few customers onboarded to Capella, the biggest problem that we faced as a DBaaS offering was the fact that all the infrastructure was deployed in the customer's AWS account. So we didn't really have direct access or certain privileged access to all the infrastructure that existed there. The configurations were all set up, and sometimes, due to some human errors, these configurations could be edited, and we had no control over it. That made supportability a big concern at that point. There was also, as a result, reduced agility, and it also kind of restricted us to upgrade our database version, for example. Because we actually had Kubernetes, even though there was no database compute deployed, and if customers required idle time to hibernate their clusters, we still had some amount of infrastructure continuously running in the AWS accounts. And that's where the infrastructure costs were kind of skyrocketing for the customers. And finally, because we used Kubernetes, and it was a fully managed offering at that point, right? We did not control the upgrades. They were kind of forced upon, and we had to rely on the upgrades as defined by the Kubernetes managed service. So at scale, we realized that we were building a cloud product, but was it really easy and maintainable? Was it extensible, right? And these were some of the questions we started asking ourselves. At this point, we decided there was a need for a generation 2.0. At this point, I think the thought of actually deploying and managing infrastructure in public cloud was the next generation or the next direction that Capella had to take. This is when we realized that we have to procure and manage our own AWS accounts on behalf of the customers, manage the infrastructure, while keeping in mind that data isolation and integrity are extremely crucial to customers. So DBaaS Generation 2.0 was built on 4 pillars. The first one was cost. I think the key goal to any company or any product is to lower the TCO for your customers. So if we went to them and told them, hey, you use Capella and we'll manage the entire cluster lifecycle for you, they'll be like, yes, but at what money, right? So our goal was to reduce the total cost of ownership for our customers by providing benefits and value-added services such as cluster hibernation, lean and very use case-driven configuration templates. If somebody had a use case where they were using, say, mobile applications on a cruise ship, they would probably have a configuration where they have to deploy our edge management services as opposed to, say, a query engine, right? The second goal was to accelerate, which means as compared to our generation 1.0, where we had all of these barriers to adoption, where there were security concerns and upgradability concerns, the generation 2.0 was meant to accelerate the adoption by making it simple. So I think what I'm saying is, designing DBaaS, it was a big systems engineering problem, but at the core, we had to keep the architecture simple and manageable. Agility, that means it should have been easier to migrate from on-prem to cloud. If there's a customer that's already using Couchbase, how can we make it a one-click deployment or an easy migration onto the cloud without giving them downtime? Can we serve reads and writes on-prem as well as cloud at the same time and eventually just turn off the on-prem cluster? What did that journey look like? We had to really deeply think about that. And supportability. Definitely, we have a big support team because it's a fully managed offering. That means we are 24/7 supposed to be in support of our customers. So how can we make the support team's life easy? By giving them the levers and hooks to manage the infrastructure on behalf of customers. And I think these are such generic tenets that operate and apply to any company that you're trying to build from ground up. So a quick change in the generation 2.0, we had the same control plane, we had the same API clients. It's just that the data planes were now completely hosted and managed by Couchbase. What we did was if one customer, a brand new person or brand new user signs up on cloud.couchbase.com, we assign one AWS account, one GCP account, and one Azure subscription to that customer. And we deploy all the infrastructure for the customer in these dedicated, isolated cloud accounts. That's where you get your data isolation, security, and as well as scalability, because the entire account is yours. And then the customer applications can directly connect to whatever runs in the data plane via public internet or private internet. So I think when we started building DBaaS, we had to be really intentional. The intentionality was that we wanted to keep our core offering, which is the database, open source, because that's how we started off. And then we still wanted to leverage and provide value-added services to our customers by just hooking in operational features, such as multi-cloud orchestration, multi-tenant systems, billing, metering, providing valuable insights into workload monitoring, and so on. Even tighter access control and RBAC on cloud with IAM policies, let's say, on AWS. And there was a lot of benefit that people drew and our customers drew from that offering. So there was definitely benefit. So if we have to think of what it takes to build DBaaS, which is a simple architecture, easy to access, easy to maintain, while isolating data, security, and integrity, there are a few points that come to my mind. The first one is we built DBaaS as a multi-tenant platform, which means every time we onboard a new customer, we have to provision and assign a new cloud account to that customer, which means we have to maintain a pool of AWS cloud accounts and keep assigning those accounts to new customers as they sign up, which means we have to manage the quotas of all the AWS resources that we want to deploy, and that too on all AWS regions. So there's a whole new thing about data, about tenant onboarding and tenant isolation. That took us a while to build in the control plane. The second one is billing and metering accuracies. We have a lot of vendors today which make billing really easy and reconciliation easy, but metering is a very crucial aspect when it comes to building a billing system for the DBaaS platform. Actually counting the number of reads and writes happening on your database, sending that information out from the data plane, and reconciling on an hourly basis, on a monthly basis. And for whatever reason, if there is a failure where this data doesn't come out of the data plane, well, okay, I don't know what to do. So we face a lot of these pitfalls where reconciling at the end of every month, ensuring that we are billing our customers the right way, and we are being compliant, and we're able to prove that this is how much they used, and this is why you're getting billed for that much amount, was a challenge. Database availability at scale. The thing with databases is it's at the heart of any product. If a database goes down, you can't use your application, right? You'll see an error message, and that's a very bad experience. So all of our customers, and all of them use like a database and Couchbase at scale and at production. The main thing that is really important for them is high availability and zero downtime. To provide that in a DBaaS offering and also provide them with an ability to automatically scale their cluster and compute while keeping the data always available is a big challenge. It's a typical distributed systems problem where you have to spin up new compute before you remove the old one, but much more than that, right? So we were able to leverage some of the offerings that Couchbase has with multi-dimensional scaling, where you can scale query service separately, you can scale your indexing service separately, and it's really great, but just doing that in cloud is still a challenge. And especially building it from ground up, that's a big one. the customer journeys, and those really matter, right? So with DBaaS, if you have to sell any cloud product or any SaaS product, I think you need to think of how can we onboard customers and then give them the benefit of using this product before they pay us the money, right? So we had like different plans like free tier to enterprise and supporting our customers through the journey of transitioning from a free trial experience into a paid experience was also a big one, because we had to migrate them. We had to ensure that for free tier, we bore the cost as a company. You know, the customer did not pay us. So our architecture, the control plane, and the data plane systems for free trial was completely different than our paid offering. And we had different challenges and different problems. With free tier, people just want to use and try the product. They want to see the benefit of Couchbase, but they don't really care about data isolation as such. So solving for different architectures and supporting different customer journeys meant that we had to actually support and keep enhancing the control plane at every step of the way. As Steve mentioned, Couchbase is not just a NoSQL database. We have mobile, and we serve agentic apps and workloads and big workloads at the edge, like with Princess Cruise Line and Carnival, right? Which means that we have a bunch of product lines like Sync Gateway, which is our edge offering. We have an analytics database offering. We have vector search. And with every new offering, which is a differentiator of Couchbase, bringing it onto the cloud is yet another lever and a hook inside the control plane. We have to tweak the control plane at every point in time. So now think about it. Had this been easy to not keep changing the control plane each time, but to just purely focus on the differentiators that Couchbase has, would have really accelerated our journey. And of course, there's cloud provider differences. The control plane that we built had to be cloud agnostic. It had to be resilient and extensible. So doing that with the different cloud technologies that are there across AWS, GCP, or Azure, we had to keep supporting and keep in front of it all the time. Cool. So delivering a great DBaaS isn't just about running the database. It's much more. It's about actually building a platform that manages the infrastructure behind the scenes, and it does it so seamlessly that it's abstracted from the customer, but it's the most important and the crucial part for a good customer experience. And without that platform, just building DBaaS wouldn't have been possible. Another thing I think I learned the long way is that the journey of building Capella was not in days. It took us years to get here. It was a multi-year and a multi-architectural decisions-based journey. So it would have been really great if it would have been just a few months or a few days to build, you know? And the most important thing, customer experience is a really core systems engineering problem. We're all engineers at heart, and every time we are building a new tech product, we have to realize that some of the decisions that we make early on in our 0 to 1 journey catapult us into success in the 1 to N journey, right? So choosing the right tools in your 0 to 1 journey really matter. And that's where I think the way we decided to build Capella, the way we decided to adopt and position Capella, first starting off with AWS on the marketplace, and then with a managed offering with AWS, and then soon with other cloud providers, was really useful in that sense. A few success stories. Capella by the numbers. So after we launched the second generation, a fully hosted DBaaS offering, we were able to prove and show to our existing customers who are on-prem that moving to Capella would reduce their TCO by 40%. Had they have to like manage and deploy the entire database by themselves, they would be paying 40% more than they would if they moved to Capella. There was a very fast developer adoption rate that we saw. Our free tier offering is perpetually free. Anybody can go and sign up on cloud.couchbase.com, spin up a cluster, try it out, even use it for a long time. So it's completely free forever. You don't need a credit card, anything at all. So we saw that when we launched this perpetually free trial experience, almost 60% of those signups converted to paid offerings, which was great. And some of our biggest enterprise customers, like Princess Cruise Lines, Carnival, they're all on-prem. Migrating them to Capella was a breeze. They are now migrating, and 3x of their workloads have been migrated. So I would like it if you all can go to cloud.couchbase.com, sign up, and just check it out. It's an open source database, which is NoSQL, fast, and it's meant to serve all different types of applications, from agentic AI to mobile applications. You don't have to worry about data schemas. You don't have to worry about evolving data schemas because it's all JSON and it has no structure. We also, by the way, support agentic apps for unstructured data, so that's available too. And these are some screenshots from the website as well that please do check out. That's it. Thank you.
All right. So our last presenter today stays on the theme of data storage, but now at mega scale. I'd like to introduce Varun Madan with OneHouse, and he's going to talk about their universal data lake and how having a quality data environment is essential to creating agentic applications. That's it, Varun. Turn it over to you.
Awesome.
Thank you for closing us out today.
Thank you so much. Thanks everyone for. All right, thank you so much. Thanks everyone for being here. Hopefully, like this is the last session, you guys still have the focus, and I'll try and connect everything together. So everything from like data coming from Kafka to data being in like data stores like Couchbase, and then like using something like Array to process the data. And of course, control plane always stays the focus. My name is Varun. I'm the head of engineering at OneHouse. I started my career right here at AWS. I was here for 8 years. Was kind of fortunate enough to build some of the early systems around EC2. Moved to Oracle Cloud. That was kind of my first experience on taking something open source and turning it to SaaS. Believe me, it's kind of its own skill set, but I've been doing that since. I was at Confluent, kind of moved, helped take Kafka Streams to KSQLDB. So that's kind of example of an open source to a managed product. Also managed Kafka Connect. And now at OneHouse, focusing on taking an open source project called Apache Hoodie and turning it into a managed data lakehouse. So before there's a lot of terms I threw in there, so maybe let's just spend a few minutes talking about what is kind of a data lakehouse, why does the world need a data lakehouse? At least I needed to kind of figure that out when I joined the company. So I think we all know like data warehouses. We've kind of traditionally used data warehouses for analytics. They help with transactions, store data in columnar file formats. And data warehouses, like if I go back like 10-ish years or so, mostly used to be on-prem before we had the Athenas and the Snowflakes of the world. And they were kind of used for real-time analytics. Then about 10 years ago, we had that kind of transition of kind of moving these to the cloud. We also were kind of fortunate enough to kind of do the storage and compute separation, gave us better scalability, things were fully managed, so you don't have to kind of go think about having a person managing these data warehouses. But they were still kind of typically optimized for kind of business intelligence kind of use cases. And then people started having a lot of data. In the last 10 years, what's changed is like data's flowing everywhere. It was IoT to begin with, and now it's kind of all the AI use cases. Nobody wants to delete any data because God knows when we'll need that data, what for. We want to train models on it. We want to do so much with data, right? So we said, OK, let's do data lakes. But what is a data lake? I don't know. So nobody kind of ever kind of came to a consensus what a data lake should be. People just started throwing files on S3 because, hey, we all love AWS. S3 is cheap. Let's throw all the data on S3, right? But over time, we kind of like had to start think about like how we'll kind of like format these files. How would we kind of access these files? There are multiple kind of data formats floating around. Some data was structured, some was not. We had to kind of figure out when to kind of apply schema to those things. So it was complex, to say the least. Like we had the data, but using the data was not easy. Then we kind of started even like using different SQL engines. We started using for kind of machine learning. The primary reason we had data lakes was cost effectiveness. We didn't want to have all these servers. We want to do parallel data processing. Like MapReduce was big around that time. Everybody was kind of using Hadoop and whatnot. But they were still pretty hard to kind of manage and build. Data quality was a big challenge. Again, if you don't have schema to them, data lakes were slow and inefficient. So that's kind of lays the ground for why we needed something like a data lakehouse. So what does a data lakehouse do, right? So at the heart of it, we still have the cloud storage. We're still storing these files on S3 because it's cheaper, and that's kind of easy to do. But it adds a transactional layer on top of it. So now when you're kind of doing like updates and deletes, you don't have to think about concurrency. And the few formats came about to standardize how we're storing these. At the end of the day, we're still storing data in columnar formats like Parquet and ORC. But now we build a few metadata layers on top of it that make it easy for us to kind of access this data and query this data. The top 3 formats out there are Hoodie, Iceberg, and Delta. The new formats coming out around like Lance and Pymon. We added kind of a few table level abstractions. So now you can start kind of thinking about these files rather than just abstract data in S3. You can kind of think about it as like tables and files. Kind of we used to doing that with data warehouses, but those concepts were missing from the lake. So we kind of added that metadata on top of it, right? And we also kind of enabled faster processing of this data. We kind of thought about how can we incrementally process this data? How can we have like write-ahead logs on these data? How can we have indexes, for example, right? Because those concepts we know for a long, long time, but they were missing on lakes. Yeah, so at least, and I talk about indexes. Not all the formats have indexes. I come from a company that's OneHouse, where our founder was one of the initial committer builder of Apache Hoodie project, and that's one of the projects that thinks about like having indexes on lakehouses. Not all formats do, so they all have their pros and cons. So just summing up kind of what I just talked about, right? Like we had warehouses, lakes were coming about, and then like on the lake world, we had like Hadoop to begin with, then Spark became a big thing, Databricks happened, and different formats happened. And on the other side, the data warehouses kind of went to cloud. But now most of the data warehouses have a lake. So Snowflake supports a lake, Databricks supports a lake. So we kind of are at a time where over the last year or so, it's all kind of converging at one place. So to end up kind of the summary, right, like data warehouses were built for BI. Lakes were initially built because we have all this data. We want to run AI models on it. We want to train the model on that. Lake houses are kind of aiming to kind of blend the best of both the worlds. So that's kind of the background on like data warehouses and data lakes and data lake houses. So the project, the open source project that our company took from being an open source project to a SaaS service, the project is called Apache Hoodie. It started at Uber in 2016, where Uber had like a ton of kind of real-time change logs happening, coming in Kafka, like 120 terabytes of data ingested like every 8 hours. It was really like a real-time need for the business. They were struggling with kind of ingesting this data and being able to kind of compute the data in an efficient manner. And they needed like really fast, like minute level latencies, right? So they built this system that kind of gave database style abstraction, near real-time ingestion, faster upserts, and kind of the asset guarantees, which were kind of missing on top of lakes at that point in time. So over a period of time, this project is now kind of 1.0 this year. We've kind of built a ton of stuff, including kind of the things I talked about around different indexes and concurrency control and whatnot, things we are kind of used to having on data warehouses. used by a ton of companies, including Amazon. So if people use Amazon EMR, like a huge amount of folks who use EMR actually store their data in Hoodie format. Ton of other big companies out there are using Apache Hoodie. So that goes to now the SaaS part of the service. So we decided to kind of form this company about 4 years ago based on the Hoodie project. And the whole idea was that we want to provide kind of a fully managed data lakehouse for AI and ML workloads and others as well, right? So people were still doing it, right? So like that's the thing with open source and managed products. Like you can like take the open source product and run it, but it's not easy. You have like complexity around deployments. You have to figure out how to performance tune it. You have to figure security and compliance, especially when you start looking at enterprise scale. And you have to think about quality and resilience of your solution, right? Prior to kind of like it being a fully managed service, like customers were still doing all the things they're doing today. So you can use like something like Fivetran or Spack to kind of use your ingestion. You can use certain formats to kind of store your data. You can again use different engines to transform the data. Then you can use everything from Snowflake to Ray to DAF to kind of process the data. But again, like it's not easy. It's slow, it's expensive, you're kind of locked into certain ecosystems, right? And that's what we kind of were targeting to break out of. So we built this end-to-end platform where you can store the data in any format. We have built our own compute runtime, but we kind of support ingestion from multiple places. We support kind of running SQL and Spark jobs. You can do table optimizations. You can use different engines to process the data, and you can query your data from various different sources. So what that gives us basically is like we are able to get an end-to-end solution that's fast, that's cost-effective. Like we have customers who basically talk about getting 10x the performance as compared to Databricks at half the cost, and that's something we love to hear. And it's also interoperable across different. So you can really like ingest the data from, let's say, from Kafka, have it in one house, query that data from Athena, from BigQuery, from Snowflake, from Databricks, the same set of data without making multiple copies of it. Again, one of the things you think about is like, hey, you have an open source product. Now you're giving a managed service. Of course, you're giving some value by making it like easier for people to run the product, but you have to kind of go differentiate beyond usually. For us, we focused on two aspects of differentiation. First was performance. So we basically said like our platform is going to be the most performant. So we compared our platform to kind of all the other kind of Spark-related compute platforms out there. And we've been able to kind of achieve like 30x fastest queries compared to others, and including open source, by the way, right? Because in some ways, at the end of the day, you are giving a managed service, but you have an open source product as well, and you have to differentiate with that as well, right? And the second differentiator for us is openness. So kind of touch on it, right? Like our focus is that you can use any engine, any catalog, any kind of table format with our product. So considering the topic today is about kind of going from open source to SaaS, so I want to touch on a few challenges that we had to kind of go through to make this open source product a SaaS service. So first of all, we had to kind of define what architecture are we going to focus on, right? When we go to SaaS, we usually think about like what is the kind of tenancy model, right? Like what parts of a system are going to be multi-tenants versus single tenant, right? It being a data system, so first thing was clear to us, like we wanted a control plane to be multi-tenant. They didn't make any sense to have multiple kind of control planes. But we did decide to keep our data plane single tenant because a lot of our customers were enterprise customers who want to keep their data within their VPCs. They don't want like us, even as like the providers of the service, to have access to the data and touch that data, right? Second thing we had to think about, even touching on that, right, data residency. So yes, we might not be processing the data, but where does that data sit? So even in that case, like it was very clear our customers wanted the data to stay within a boundary. So today the way it works is our service runs on top of, let's say, AWS. The data sits in S3. The data plane runs in the VPC that accesses the data from S3. We, as the runners, as the people who are managing the service, don't kind of touch that data at all. It never comes into our network boundaries. Then we had to think about, okay, what all do we need to kind of run to kind of maintain this service, right? So first of all is Apache Hoodie. That's the open source product that we are turning into a service. But then there are a lot more things that you have to worry about, like where is this going to run? So it's like, okay, we need to manage Kubernetes. On top of Kubernetes, like Spark isn't like the easiest thing to run in the world. And also our users worry about like one installation of Spark. So let's say you're running Spark and you have ingestion happening on it, but you're also kind of running a very heavy query on it. Now you don't want some random SQL query to actually slow down your ingestion, right? So you have to kind of think about how do you kind of manage different kind of parts of the service that you're running. So we had to build, using an open source product again, some cluster management. And of course, you have to think about like how you're going to monitor and log, because again, this is running in customers VPC. If things go down, I'm still responsible. My team is still responsible for kind of like taking care of this product, but we don't have direct access to all the machines where this data plane is running. The main challenges we kind of even ran into is when you are running kind of like multiple data planes, no matter what you do, there are certain customers who don't want you to upgrade at certain times. You will end up with multiple versions of the software. And when you have kind of outages, you have to think about like, hey, what version is running where, and why does certain version have certain issue? You will end up with data systems, like there's a lot of configurations. Spark is such a tunable system, so you end up with kind of multiple different configuration of your system as well. And we're running this in customers' environment. All customer environments are different. Like every kind of enterprise customer we deal with, they tune their VPCs differently. They have different networking setup. They have different access permissions. So you have to kind of deal with all those different kind of customer environments. By the way, this is almost sounding like a pitch for OmniStraight. It is intentional, but these are real challenges that we run into. The current pain points that we're still dealing with is how does my team get access to customer environments? Because again, these big enterprise companies don't want like my engineers to have unrestricted all the time access to customer environments. We're kind of still figuring out like, hey, what kind of metrics should be like when we started the service, we will actually take out all the metrics, store it in like an central store, but that was turning out to be very expensive. We can't just take out every log from a customer environment because this might have confidential information in there. So these are still kind of pain points we are still kind of trying to figure out, and as we kind of build the service, right? All right, that's kind of high level what we're building. I want to show a demo. Hopefully things will run, but I want to kind of show you the initial part of how do we kind of get data into a data lakehouse, and then how do we kind of use that data using something like Ray. So let's go to the first part. This is the OneHouse console. I have kind of a bunch of like data lakes over here. So one of the core concepts is data sources. So we support a lot of different sources where we can kind of get the data in from. So S3, Apache Kafka, concurrent version of Kafka, and whatnot. As you kind of like, let me show you one example at least of getting data in. So I'll go to a stream capture. So source is when you just define a source. So this is its configuration, so I won't kind of spend time on it. I'll add a new kind of stream capture where the source is already defined, and I'll pick one of the, let's pick up the Confluent. Let's pick up Kafka. It's interesting. You define kind of what kind of format do you want to write the data in. Mutable is actually honestly where things are interesting, and that's where even Hoodie shines because of having those indexes. We're able to kind of do updates more efficiently. Data lake houses are near real time, so we support anywhere from 1 minute to 24 hours of sync frequency. And as I chose that Kafka topic up there, what happened is it auto-populated all the topics that are in that Kafka source. So I can pick any of these. Let's say I pick this one. I already have it, so I won't go through it, but I'll show you how can you kind of configure this data source. So what you can do to begin with is you can define the schema you want to apply to this data. And if the schema validation fails, you can decide to quarantine the record or fail the entire pipeline. You can apply different kind of transformations. We have in-house transformations, but we also let you bring your own transformations. You define the record keys of your data, the partition keys. And for Kafka, you kind of decide, hey, where do you want to start ingesting the data from the earliest or the latest offsets. And then you choose the lake you want to put that data in, the database. So catalogs are a key concept. So I kind of talked about when I was introducing data lake houses that One of the things that all the lakehouse formats have, like Hoodie, Iceberg, Delta, is they have metadata on top of the Parquet files. And a lot of this metadata, not all of it, but a lot of this metadata is stored in catalogs. So we support multiple catalogs. In this case, I'm using the AWS Glue catalog. And then you choose where do you want to run. So we have a concept of clusters. So remember I was talking about cluster management is one of the softwares we have to deal with. So you choose a cluster and you start capturing the stream. Once you start capturing the stream, the data shows up. So in this case, I think I was looking at the retail scans. So for example, the retail scans data is here. You can kind of like see the number of records and like how big it is. It'll take a second to load, but hopefully it will load. So this has kind of like 3 billion records, 450 gigs of data. Yeah, so that's kind of the ingestion part of it. So I have the data now. What do I want to do with it? So we can do a lot of things. I want to focus on kind of using Ray to use this data. So what I've done, actually, I've ingested some data that is in one of the quick starts of Ray. It's breast cancer data that has some data points that helps you train model on detecting breast cancer. So I ingested this earlier. I'm not going to go through the ingestion. So it kind of shows like the data I took in, the records. I ran a SQL query earlier to kind of show all the data that's ingested into this table. But what I'm going to do now, I want to have a Ray cluster. So go to clusters. I already have it, but I'll show you how do we kind of start a new cluster. So we have this concept of open engines. So you can have a Trino cluster, a Flink cluster, or a Ray cluster. So you can choose a Ray cluster. You can decide how many kind of CPUs and GPUs you want to give to it and kind of press start. I won't do that right now because it'll take a few minutes for it to start. I already have kind of a Ray cluster over here. So what I'll do is, and when you have this Ray cluster, you get an endpoint to connect to. So I right now connected a port forward so I can access this Ray cluster on my local machine here. It is running here. I'm going to run this script where I'm going to train a model. What this is going to do is going to read the data with that I ingested. And then it's going to basically process the data, create the data set, drop some few columns. We're going to initialize Ray. We're going to use XGBoost to actually train that model. And then we're going to look at the predictions. And to run it, what I'm doing is basically I'm going to do a Ray job summit. The beauty of Ray is it supports like different runtime environments. So the environments over here, I have Hoodie, of course, Ray, and XGBoost. So it's pretty simple. You can just like define these. So even one of the things to look at right now, going through all this, I didn't install anything. Like everything is kind of self-connected. You ingest the data. It's available to different engines, including Ray. So let me run that script. Hopefully the demo gods. So this connects to the Ray server, which I'm local port forwarding to my local machine. It's going to start reading the data. I'll give it a second. I have the script fully run. It takes a few minutes because it actually kind of runs all the training. It's doing it. I'll believe this will happen. At the end of the day, it's able to kind of take all the data that I ingested into the system without making any kind of like configuration. Ray has access to the data, is able to take that data and train a model on it, right? That's the whole idea of having kind of an end-to-end data lakehouse. And you can see the Ray dashboard over here. So you can see this job is running. And kind of you'll be able to see the results soon. That's it. Thank you. You can, if you want to try OneHouse, it's on onehouse.ai. I'm reachable on X and on LinkedIn. Thanks, everyone.